All right, now we're on slide number 5 of PowerPoint 4B that deals with solution concentration. On this particular slide, we're going to see how we can use solution concentration in stoichiometry problems. And I have a stoichiometry problem here on the board that uses solution concentration. The problem is listed again on on slide 5 of your PowerPoint. We're asked what mass of calcium carbonate is required to completely react with a certain volume of a certain concentration of hydrochloric acid. So this is all review. I mean, at this point we've learned everything we need to do this particular problem. You've learned about molarity, and you've learned about solution concentration, and you've learned about stoichiometry as well. So we're really just putting together some things that you already know how to do. But nevertheless, this is the chemical equation that'll happen, and you've seen this in class, if we add hydrochloric acid to calcium carbonate. If you were in class and you saw me add the hydrochloric acid to the marble chips, this is the reaction that took place. We're trying to find out what mass of the marble chips will completely react with this volume of this particular concentration of hydrochloric acid. Well, this is really the only portion of the chemical equation that I'm going to need because it contains the relationship between the two things involved in the problem, hydrochloric acid and calcium carbonate. So I'm going to focus in here on the stoichiometric relationship. Now we've got to remember what units this particular equation speaks to. It doesn't speak to grams, it doesn't speak to volume, it speaks to number or moles. So I've got to convert the information I have into moles so I can use this particular equation, so I can use this relationship. And we get that right here. These two pieces of information are going to allow me to convert the concentration of hydrochloric acid and its volume into moles. It's very simple. I'm just going to write the concentration of hydrochloric acid given. Notice how I'm going to write it. I've written it as 0.750 moles of hydrochloric acid per liter. That's what this big M means. That's what molarity means. And I see a mole here, which is going to help me, because the mole talks to this equation. I've got to get rid of this liter, though. This is going to help me do it. I'm going to multiply this by 0.025 liters of solution. I'm going to pause here and make sure you understand what I've done here. I've taken the concentration and I've multiplied it by the volume, and by doing so, look at that, I get moles. Also recognize I converted 25 mils to 0.025 liters. That should be an easy conversion for you by now. But the units tell me if I take a concentration and multiply it by volume in liters, I'll end up getting moles of that particular substance. So let's do that. 0.75 times 0.025, 0.01875 moles of hydrochloric acid. Now I've converted my concentration and volume into an amount that I can use in this equation. Moles talks to this equation. You know that from the stoichiometry stuff we've been doing. So, I'm going to take my 0.01875 moles of hydrochloric acid, and I need to convert that into a mass of calcium carbonate. Well, the first step is to convert to moles of calcium carbonate. I can do that here. 2 moles of hydrochloric acid are going to react with every 1 mole of calcium carbonate. Make sure I did that right. Moles of HCl, yep, those are going to cancel. And through the equation, I was able to convert moles of hydrochloric acid to moles of calcium carbonate. I want to know the mass, so I'm going to need to convert my moles of calcium carbonate into grams of calcium carbonate. And of course, we do this conversion by looking at the atomic masses on the periodic table. Calcium is roughly 40 grams per mole. Carbon, there's one of those are 12 grams per mole. And with oxygen, we've got 3 times 16, that's 48 grams per mole. What does that come out to? About 100, doesn't it? 40 plus 12 plus 48, yep. That's 100 grams of calcium carbonate for every mole of calcium carbonate. So there we have it. 100, I'm going to ignore the ones, times 0.01875, and we'll divide that by 2. Almost a gram. 0.94. See, I got 4 significant figures here, but only 2 significant figures in my volume, so it's probably going to be about 0.594 grams of calcium carbonate to the appropriate number of significant figures. If you look, there's a second problem on slide number 5 of the PowerPoint. You should probably take some time and look over that one. If you don't feel like you know what's going on with that particular problem, make sure you bring it up in class.